What if our universe is just one of countless others? What if beyond the stars we know, there are other worlds with different laws of physics, maybe even versions of ourselves? Today, let's discuss one of the most exciting and mind-bending questions in modern science. Does the multiverse exist? The multiverse is a term that describes the possibility of multiple, maybe infinite universes existing beyond our own. Each universe could have different physical constants, different dimensions, and perhaps even completely different laws of physics. This concept has been a topic of fascination for scientists and philosophers alike for decades. But before we dive into theories, let's define the term universe. Our universe is everything we can see, detect, or measure. The sum of all space, time, matter, and energy. But this is only our observable universe. Beyond it, we simply don't know. Could there be more out there? That's where the idea of the multiverse comes in. The idea of multiple worlds has deep philosophical roots. Ancient Greek philosopher Democritus speculated that there might be other worlds beyond our own. Fast forward to the 20th century, and this idea took on a new form in modern physics. Albert Einstein's theory of general relativity and the rise of quantum mechanics in the early 1900s hinted at a universe far more complex than previously imagined. But it wasn't until later in the 20th century that the concept of the multiverse gained serious traction in physics, particularly through cosmology and quantum theory. Let's explore some of the key scientific theories that support the possibility of a multiverse. One of the most compelling ideas comes from cosmic inflation. Right after the Big Bang, the universe expanded at an incredibly fast rate for a fraction of a second, a process known as inflation. This inflationary model, developed in the 1980s by physicist Alan Guth, explains why the universe is so homogeneous and why the cosmic microwave background radiation is so smooth. But here's where things get interesting: the theory of eternal inflation. This idea suggests that while our universe's inflation ended, other regions of space-time may continue inflating, creating other universes in the process. Imagine the universe as a bubble, and our bubble is just one in a vast cosmic foam of infinite bubbles. Each bubble could represent its own universe with its own unique properties. This is a form of what's called the Level 1 multiverse. Now, let's move to the world of quantum mechanics, the science of the very small. One of the most famous ideas in quantum theory is the concept of superposition, where a particle can be in multiple states at once until observed. But what if this isn't just a quirk of measurement? What if every possible outcome actually happens in separate universes? This brings us to the many worlds interpretation of quantum mechanics, first proposed by Hugh Everett in 1957. According to this theory, every time a quantum event has multiple possible outcomes, the universe splits, creating parallel worlds where each outcome plays out. This idea forms what we call the Level 3 multiverse. It's an interpretation where an infinite number of universes exist simultaneously, each following a different path based on quantum decisions. This theory has profound implications. In one universe, you might choose a career as a scientist. In another, you're an artist. Every decision spawns a new universe, and in this infinite web, every possibility is realized somewhere. Another area where the multiverse concept comes into play is string theory. String theory posits that the fundamental building blocks of the universe aren't particles, but tiny vibrating strings. One of the challenges of string theory is that it works in multiple dimensions. Not just the 3 dimensions of space and one of time, but up to 10 or 11 dimensions. According to some versions of string theory, the laws of physics could be different in other regions of space, giving rise to a landscape multiverse, a vast range of possible universes, each with different physical constants. In some universes, gravity might be stronger. In others, stars might not even form. This theory provides a framework for what's known as the Level 2 multiverse, but not everyone is convinced. Critics argue that the multiverse is a theory that goes beyond the realm of science because, by definition, other universes are unobservable. The scientific method relies on testable predictions, but if we can never observe these other universes, how can we prove they exist? Some scientists believe that invoking the multiverse is unnecessary, that we can explain the properties of our universe without resorting to infinite others. They argue that we should focus on theories that we can test within our own universe. And then there's the philosophical critique. If every possible outcome happens somewhere, does that mean free will is an illusion? Despite these challenges, researchers are exploring ways to find indirect evidence for the multiverse. Some scientists suggest that if other universes exist, they might leave imprints on our universe, such as subtle anomalies in the cosmic microwave background radiation. Others are searching for mathematical models that could point toward a multiverse. As our understanding of the cosmos deepens, new technologies may help us detect signatures of other universes, or at least push the boundaries of what we know about our own. But for now, the multiverse remains a tantalizing mystery. So, does the multiverse exist? We don't have a definitive answer yet. Theories from inflationary cosmology to quantum mechanics to string theory all suggest the possibility, but proof remains elusive. What we do know is that the multiverse challenges us to think beyond the boundaries of our known universe and consider a reality far larger and more complex than we ever imagined. Whether or not we ever prove the existence of the multiverse, the search itself continues to push the limits of human knowledge. The universe, or multiverse, is an endlessly fascinating place, and we're just beginning to explore its mysteries. Thank you for watching. If you enjoyed this video, please like and subscribe.